tutorial, and in our tutorial today we're going to look at a question in chemistry which is coming from more concept, and the question reads 8.0 grams of impure sodium hydroxide solution reacted with exactly 40.0 centimeters cubic of 2.0 mole per decimeter cubic of sulfuric acid. A. Write the balanced chemical equation for the reaction, including state symbols. So sodium hydroxide, it's a base, and sulfuric acid, it is an acid. So when a base, which is sodium hydroxide, was to react with an acid, we are going to have a salt by the name of sodium sulfate, okay, plus water. Okay, plus water. Now, if you look at this equation, you discover that it's not balanced. On the sodium aspect, which are on the reactant, we've got 1 sodium. On the product, we've got 2 sodium. So what do? You put a 2 there. Okay, that makes sodium to be balanced. But sodium is balanced. Okay, what about the hydrogen? Hydrogen on the reactant, while there's sodium hydroxide there, we have got 2 hydrogen and 2 hydrogen on the acid, which makes it to be 4. And on the product there, we have got 2 hydrogen. So to make it 4, we're going to add a 2 there. So that makes hydrogen to be balanced. Okay, the sulfur, we've got 1 on the reactant, 1 on the product. Then the oxygen on the reactant, where there's sodium hydroxide, we've got 2 oxygen. And where there's acid there, I've got 4 oxygen. Together they make up 6 oxygen. If you look at the product, on sodium sulfate, we have got 4 oxygen. And then on water there, I've got 2. If you add, it gives us 6 oxygen. So this chemical equation, it's balanced. Okay. So the next question, we are told to construct a simplified net ionic equation for the reaction. So when we're doing this, there are necessary steps that we need to follow whenever you want to write a net equation. Okay. One of the steps is that number 1, your equation should be balanced. So step number 1 will say balance, okay, the chemical what? The chemical equation. So now our equation is already balanced. What do? We'll go to step 2. Okay, step 2, it tells us to split, okay, the compounds. Okay, that are in aqueous state. In aqueous state only. So if you look at this one, we've got the sodium hydroxide there, which is in aqueous state. So we will say 2 there, sodium, okay, plus the 2 there, hydroxide, because that 2 is for everything that is there. Okay, plus the sulfuric acid, we're going to have 2 hydrogen, okay, positive charge. Then the sulfur there, sulfate, radicals, they remain unchanged. Okay, being equal to, you split the sodium sulfate. So since sodium, there are 2 sodium there, we'll put a 2 there. Okay, sodium is a metal, it forms a positive charge. Okay, plus the sulfate there, which is a radical with a negative charge, plus the water will not be splitted. Why? It's not in aqueous state, it's in a liquid state. So we only split those that are in aqueous state. So step number 3, we cancel the spectator ions. Spectator ions. Okay, we are looking at ions that are found both on the reactants and on the products. So those ions, we have got sodium there. Okay, we have got sodium there. In fact, sodium was supposed to be a positive charge here. So we have got sodium here, sodium ion, and the sodium ion you cancel. Then the sulfate ion there. So we are going to remain with the hydroxide ion and hydrogen ion, which is going to give us water. So step number 4, we're going to say rewrite, okay, the ionic equation. Okay, so that one is going to be 2OH, which is hydroxide, okay, plus hydrogen ion, okay, being equal to 2 water there. Okay, now as you can see, the hydroxide ion has got a 2, then the hydrogen ion has got a 2, and the water has got a 2. So we can divide there, okay, because that 2 is divisible to each other. So we can divide with a 2 there. Okay, we are simplifying it further. We're going to have the hydroxide plus hydrogen, okay, plus what? Plus water there. Okay, so that is a simplified ionic equation. Okay, we continue. We will look at the next question. So what's the next question saying? We are told to calculate the number of moles for sulfuric acid that reacted with the 8.0 gram of impure sodium what? Hydroxide. So we'll focus on the equation. Okay, of course, the balanced equation. So our equation was like this. Our equation was like this. So we had sodium hydroxide plus, okay, sulfuric acid, which gave us sodium, okay, sulfate, okay, plus what? Plus water. Now, these numbers that you add, okay, when balancing, they are the ones that we describe as the mole ratio. So as you can see there, you discover that there are 2 moles, okay, of sodium hydroxide, which had to react with 1 mole of the acid, okay, to give us 1 mole of the salt and 2 moles, okay, 2 moles of what? Of the water. So in this question, we are being told to calculate the number of moles that reacted with the number of moles for the acid, which is sulfuric acid, which reacted with the 8.08 grams, sorry, 8.0 grams of sodium hydroxide. Now, if we are to carry on the data, you look at the information that were given there. Okay, you discover that we have got the volume I've got the volume of sulfuric acid. Okay, the volume there for sulfuric acid, let's check in the question. The volume is 40 centimeters cubic, and the molarity there, that is 2.0 mole per decimeter cubic. Okay. So our volume, that is 40.0 centimeters cubic. Okay, then the molarity, it's 2.0 mole per decimeter cubic. Okay, so we need to find the number of what? The number of moles. Okay, so take note that number of moles is equal to the molarity, okay, multiplied by what? Multiplied by volume. But this volume is supposed to be in decimeter cubic. So we need to convert this 40.0 centimeters cubic. How do you convert it? We are told that 1 decimeter cubic is equal to 1000 centimeter cubic. So our 40 centimeters cubic will be equal to what? To x. So when you multiply x multiplied by 1000 centimeters cubic, we're going to have x 1000 centimeters cubic being equal to 1 decimeter multiplied by 40 centimeters cubic. We're going to have 40 centimeter and decimeter there. Okay, so you divide both sides by 1000 centimeter cubic. Okay, 1000 centimeter cubic. Okay, what are we going to have there? Cancel. Okay, so when you cancel this, the centimeter and centimeter, we remain with the decimeter. Then 1000 into the 40, we are going to have 1000 into the 40, we are going to have 0.04 decimeter cubic. Okay. Now, after finding the volume, you have the molarity there. Okay, and that molarity, it is 2. Okay, 0.0 mole per decimeter cubic multiplied by the volume, which is 0.04 decimeter cubic. So when you multiply 2 multiplied by 0.04, okay, that is going to give us 8.80 moles, okay, of sulfuric acid, which reacted with the 8.0 grams of sodium hydroxide. Okay. Next question. Next question, it was telling us to calculate the mass, find the mass of pure sodium hydroxide from the impure solution that reacted with 40.0 centimeters cubic of sulfuric what? Sulfuric acid. Now, how do we go about that one? We use the mole ratio, because we now have the number of moles for sulfuric what? Sulfuric acid, which will be very easier there. As you can see that the mole ratio there, it is 2:1 between sodium hydroxide and sulfuric what? Sulfuric acid. So what do? We shall say that this is C. Okay, I've got 2 sodium hydroxide, okay, plus sulfuric acid, okay, this is giving us sodium what? Sulfate, plus water. Okay, so the mole ratio there, the mole ratio there, it is 2 moles, okay, against 1 mole. Okay, now in a situation whereby we have 0.08 moles, okay, so how many moles of sodium hydroxide is the sulfuric acid going to react with? We're going to multiply. So X multiplied by the 1, that will be 1 what? To be X mole, being equal to 2 multiplied by the 0.08. It's going to give us 0.16 moles and moles. Okay, so we'll divide with the moles on both sides. Okay, you cancel out. You're going to remain with the X being equal to 0.16 moles of sodium what? Of sodium hydroxide. Now we are interested in the mass. We are interested in the mass. So therefore, we would say that mass is equal to the number of moles multiplied by the molar mass. Okay, so number of moles we have, which is 0.16 moles, multiplied by, we need to find the molar mass. Now what is the molar mass? Okay, this is the mass, okay, of an element or compound expressed in grams, okay, per mole. Okay, it's calculated as a sum of the mass numbers. So, for example, we have sodium hydroxide here. So the mass number for sodium, that is 23. The mass number for oxygen, that's 16. And the mass number for hydrogen, that is 1. So when you add, we're going to have 40 grams per mole. So 0.16 mole multiplied by 40 grams per what? Per mole. Okay, if you multiply that, what are we going to get? Multiplied by 40, our answer will be 6.4 grams of sodium hydroxide. Okay, so this is the mass of the pure sodium hydroxide from the 8.0 gram of the impure sodium hydroxide. So our last question is telling us to calculate the percentage purity. Okay, so how do we calculate the percentage purity, knowing that we've got the mass of the pure substance? So take note that percentage purity is equal to mass of the pure substance, okay, divide mass of the total sample, okay, multiplied by 100%. So in this case, the mass of the pure substance was 6.4 grams. Okay, then the mass of the sample was 8.0 grams multiplied by 100%. So if you punch on the calculator 6.4 grams divide 8.0 grams multiplied by 100%, you will discover that your percentage purity, okay, of sodium hydroxide is equal to 80%.